Okay, here's some quick review for the quizzy thing coming up tomorrow. Okay, the first question was pretty straightforward, that I gave you some blocks and you had to determine the density of these blocks. And I didn't give you this column, but it's just mass divided by volume. You can do those very quickly. You can see that 80 divided by 66 is 1.21 all the way down the line. Next part of the question was to suggest, well, what would happen if you were to put them into water? And how would they float, or would they float? Now it's clear that A is more dense, so it's going to drop to the bottom. E is interesting because it's the exact same density of water. You could put it anywhere. It could stay there. You could put it there, it would stay there. It would stay anywhere because it's the same density of water, just kind of anywhere you want to put it. Now B, C, and D are all less than 1, so they're going to float at different heights. C, let's start with that one. It's 0.5, so you'd find that half of it's going to be above water, half below water. 8/10 is a little bit more dense. We'd actually find that about 80% would be underwater and 20% on top. And of course, then D would be quite a bit out of the water, and about, if I can put it there, about maybe 30% would be underwater, 70% above water. That's pretty much what that would look like. Of course, if you had it in a different material, it was less dense or more dense, different things would happen. For example, if you put it in alcohol, alcohol being a density of 0.79, this one would drop a lot more. And in fact, it'd all drop a lot more. In fact, E would also drop down because it's more dense. So that's that one. Okay, question number 2 referred to Bob, I think, and Bob wanted to take off in a helium balloon. And this is still the same idea of buoyancy. So we have to in order to float in the air, you have to displace air, not water, as in a boat. So in this case, what we have to figure out is Bob has a mass of 45 grams, so that's going to be the mass pushing down, and if we change the newtons, it'd be the force. But let's start with the balloon. I told you the balloon is 35 cubic meters, and the first thing we have to figure out is, well, okay, if it's 35 cubic meters, what would be the mass of that air that it would displace? Now, since we're using cubic meters, up here I have some densities of air, and the one that would make the most sense would probably be the one that has cubic meters in it, so 1.2 cubic meters. And as you probably know already, that when you talk about mass and density-volume relationship, mass is equal to density times volume. Plug some things in. So mass is density 1.2 kilograms per cubic meter times 35. Crank it out, you get 42 kilograms. So now we know that the mass of the displaced air is 42 kilograms, and that's kind of like the idea again, the buoyant force pushing up. So it'd be 42 kilograms of mass pushing up. If we want to change that to newtons, it'd be the force, but it's a similar idea. And 45 down. Last I looked, 45 is bigger than 42, therefore he's not going to go anywhere. Now if we change it to newtons, it's still the same idea. 450 is bigger than 420. So I mean, you see, newtons isn't a really scary thing. It's just how you apply mass to force. And there's a direct relationship, of course. And if you actually looked at the newtons, it'd be 30 newtons down. Or you could say it would be 3 kilograms pushing down of mass. So Bob's not going anywhere. So either Bob's got to lose some weight, or the balloon's got to be bigger to displace more air. Okay, the last one was very similar to Bob's thing, but now it's a boat floating. And in this situation, I gave you some information again, and I said there was a boat was placed on freshwater lake. So now that's not salt water, but fresh water, pure water, theoretically. And we now know that the boat when it sits in the water, it pushes out or displaces 45 cubic meters of water. Remember, the whole point of the force of buoyancy is that force of buoyancy pushing up is equal to the mass of the fluid displaced. So in this case, then we have to figure out, well, what is the mass of 45 cubic meters of water that's being displaced? And again, fresh water. So in order to figure that out, same formula again, mass equals density times volume, which is just, remember, a reworking of density equals mass divided by volume. Since we're using fresh water, and the only one I gave you here was kilograms per cubic meter, that's the one right there. But remember, 1 gram of water, one gram of water is 1 milliliter, and 1 kilogram is 1 cubic meter. So there's that nice relationship there. In any case, getting back to here, So we have here, what is the mass of fresh water displaced? Mass equals density times volume. Mass equals 1,000 times 45. Pretty straightforward, easy math. That means that the amount of water being displaced would be 45,000 kilograms. And if we look at our little pictures now, then if the combined cargo and mass in this ship here is 4,500, and the force pushing up is only 45,000. Not a good thing if you're the boat, because this boat would be sinking. It would crash down. And do I have this backwards? Yes, I do, don't I? I think what I want to do here, I'll switch this, is I want to have this pushing down and this pushing up, because that's what we want to do here. So the force of the water pushing up is 4,500. The mass going down is 45, and that's not a good situation. They're going to sink because they're too heavy. And next question would be, follow-up, well, what if we put this in salt water? You already know that you float better in salt water, and again, the reason for that is salt water is more dense. And so if you're displacing the same 45 cubic meters of water here, but this time salt water, we do the math and we find out that the mass is actually greater because it's more dense. And now if we look at the little scenarios here, and I think I did the same thing again, probably, yes I did, that this should be turned around, which I will turn it around. So this is the force pushing up of the water displaced. This is the mass of what's in the boat pushing down. And now when I look at this and make the comparison, we find that, hey, we are going to float. That last I looked again, 46,350 pushing up is greater than 45,500 pushing down. And so in this case, that's a salt water, not for salt water. The salt water is going to push up and the boat's going to float. So all these questions are just applied density, at least basically in terms of buoyancy here. And again, the thing you have to remember is the force of buoyancy pushing up is equal to the weight of the fluid being displaced. Whether it's a liquid with a boat or whether it's air in a balloon, it's all the same thing. So I hope this helps. But you can always send me emails and ask me questions. But the quiz is tomorrow, Thursday.